Thank you so much. I am really happy to be following up a talk on blockchain because I'm hoping to provide today a very different sound than the one you just heard. So, first of all, I think it's appropriate to tell you who I am. My name is Melanie Rieback, and I am the CEO and co-founder of Radically Open Security. What you need to know is that I have worked over 15 years in computer security. I used to be academic faculty at the Free University of Amsterdam in the computer science department in computer security. And now I essentially run a penetration testing company. So these are my credentials for being able to talk about security with relation to blockchain. Now, the first thing that I want to do is I want to say, when you consider using blockchain, and when you hear talks like the one we just heard at conferences like these, of which, of course, there are many, many, many talks on blockchain these days, pay attention. Is the person who is giving this talk a computer security expert? Or is it someone who is financially vested in the technology? Is it somebody who's perhaps the founder of a blockchain company? Is it perhaps an investor who invested in a blockchain company? Or is it perhaps someone who, invested themselves in cryptocurrency heavily? You hear a lot of people singing the praises of blockchain, and they make all kinds of promises, Secure elections because blockchain, Secure supply chains because blockchain, And to be quite honest, when I hear this as a security expert, I'm going to be quite frank here, I get angry. Because I think that this technology is being incredibly oversold. I think that there are a modest number of applications that blockchain is actually good for, but I do also believe that 98% of the applications that people are talking about that use blockchain are completely inappropriate, insecure, and perhaps even dangerous. Now, I'm making some big statements here, but I'm going to be giving you some examples, and I hope in the next 15 minutes to be able to convince you why I have this opinion. First of all, everyone says, oh, blockchain, it's this great new technology. What people don't understand is that blockchain is old technology, okay? We have been doing stuff like the blockchain since the 80s, okay? Essentially, what is a blockchain? At its essence, a blockchain is a distributed hash chain with a distributed, decentralized consensus algorithm, okay? We have been doing things like, hash chaining since the 80s, with Leslie Lamport and his Lamport clocks. We have been doing cryptocurrency since the 80s, with David Chan at the CWI in Amsterdam. We have been doing distributed consensus algorithms also since the 80s. And Merkle trees also, which blockchain is based upon. Once again, you guessed it, from the 80s. So then the question is, if all of this is actually a combination of old technology, what is it now actually that's new? I'll tell you what's new. People now are willing to pay large amounts of money for it. That's what changed. So, but what people don't realize, it's always sold, blockchain, strong crypto, this is going to make everything completely secure. Look, I'm an application security specialist, and I can tell you from running a pen testing company, nothing is absolutely secure. And most of the time, the blockchain is nothing more than the crypto that is in a larger, holistic application. The blockchain is not in isolation. And typically with hackers, when they are going to go after your system, do you think they're going to go after the crypto, or do you think they're going to go after the application? Yeah. Obviously, 9 times out of 10, we are going to go after the application because there are, on average, 16 bugs for every 1,000 lines of code. Yeah? So that, of course, is the easier thing. Just putting a blockchain, in is not suddenly going to make your entire application secure. It just doesn't work that way. And if anybody says otherwise, then either they are lying or they just don't understand how security works. Or perhaps they don't want to understand how security works. So we need to understand there is a larger context: protocols, APIs, application code. Another thing is that with things like supply chains, people frequently say, well, what we're doing is we're using this blockchain, and then we're going to couple this digital representation of an object to a physical object. Okay. So then you wind up getting these companies like, I don't know, like blockchain tracking coconuts in the developing world, for all these farmers in Africa. Who isn't going to love this, right? But then let me ask you the question. How do you actually know that the digital representation of this coconut is the same thing as the physical coconut that you're tracking? If you ask somebody that, then they'll stop and say, well, RFID? Okay, hold on. So now you are reducing blockchain security with RFID security. This doesn't actually stand up to scrutiny. It's the same thing also if you have a cell phone and you're also, trying to have some kind of identifier in the cell phone, and that is then being put into the blockchain. Similarly, you can log into the cell phone as a hacker. You can break into that device and change it. So we cannot ignore the larger context that this blockchain is interacting with. Another thing that people don't understand is that immutability, which is the largest selling point of the blockchain, is also its greatest Achilles heel. Why is that? The reason is that when you create application code, once again, you've got 16 bugs for every 1,000 lines of code. So statistically speaking, you are going to have application functionality errors, which you need to fix, and occasionally you might even have security bugs, because these kinds of things happen. Now, if you are using a database, to store your data, even a decentralized distributed one, then if you have to make a change, for example, in the format of how you are storing the data, with a schema change or something like that, and of course we make these kinds of changes extremely frequently. That's what we have frameworks like, tools like SQL Alchemy for. With the blockchain, the problem is you can't fix that. And what people don't understand is if you want to fix either these application functionality errors or, more importantly, fix security bugs, the only way to actually fix that error is to literally go up to the point where you made that error, fork the blockchain at that point, and then completely rewrite everything since that point. Now, I have seen a lot of blockchain pilots fail for precisely that reason. Companies start out super enthusiastic, wanting to try out the technology, and then suddenly they realize they made an application error, and they're finding themselves unable to fix it without throwing away a whole bunch of data that they already wrote. This is a big problem. Another thing also is that, surprise, surprise, blockchain is not scalable. That contradicts what a lot of other people say. Why would I be saying this? Now, the reason why is because you need to look at the scalability of the decentralized consensus algorithms. Again, we've been working on these problems since the 80s with Liskov and Castro and the Byzantine generals problem. Now, the point is, these decentralized consensus algorithms actually do not scale. So even though, the actual blockchain itself, the distributed ledger, is decentralized, The problem is that the proof of work, but also the actual process of getting that consensus as the network grows eventually becomes untenable. We're already seeing performance problems, for reasons like this in things like Bitcoin. There's a reason why sometimes in large-scale blockchain systems it takes so long to write a transaction. Similarly, if an attacker wants to cause a problem with the system, and it's already struggling performance-wise from scalability issues, it also makes it extremely easy for an attacker to do a denial of service attack on that system. And if this kind of thing can also create race conditions, which can then cause the circumstances which might cause double spending. But there's even more problems. There's lots more problems. So again, let's come back to that whole immutability of the data being its largest Achilles heel. Now the problem is, once you put things in the blockchain, it's almost impossible to get those things out again. That's the whole point, right? But what if what you put in that blockchain is malicious? Let's say I'm a hacker, and let's say I put kiddie porn in the blockchain. Can you explain to me, please, how you're going to get that out of there? Yeah, you're going to have a hard time doing so, again, without throwing the whole thing out, forking it, and rewriting it up from that point. There has been all kinds of crap that already has been embedded in various blockchains. Just in the Bitcoin blockchain, you can find ASCII art, literally. That, there was a tribute to the unfortunately passed away cryptographer Len Sossamon in there. Exploits. There's actually a demo of a cross-site scripting attack that is embedded in the blockchain. Rickrolls, WikiLeaks Cablegate data. I mean, did you people know that this kind of stuff is already in there, and there are tools available to even be able to write arbitrary things into the Bitcoin blockchain? And again, what's the feasibility of being able to get this out again? This is problematic. Another thing that I think is extremely scary is smart contracts. See, what smart contracts are is they are remote code execution, which ultimately, look, again, I'm a hacker. RCE is like the holy grail for hackers. I want to be able to execute code, in your web clients, on your machines, these kinds of things. And there have already been cases, demonstrated cases and proof of concepts in which we have found malware proof of concept in blockchains. You have, for example, the code injection attack in EtherDelta. In fact, there's even a bytecode analyzer on Ethereum contracts called Mithril that was presented at the last Hack in the Box conference in Amsterdam. Hackers are already building tools to exploit smart contracts. But what's even better about smart contracts is once I put my malicious crap in there, guess what? You can't get it out again. So as an attacker, this is extremely convenient. Yeah. So, and if you are relying upon blockchains to always make the correct decisions for you using these smart contracts, such as in the case of decentralized autonomous organizations, again, once I have exploited that smart contract, the entire integrity and the entire model that you are basing that, that DAO on is now void and can no longer be trusted. Mining pools, we've got this trust model that the actual characters doing the mining are independent of one another. But what happens if they're not? In the case of Bitcoin and Ethereum, we have already seen a 51% attack. And this is essentially the thing with distributed consensus is when a majority of the system of the network says that there's a particular truth, then that is the truth. But then what happens if you have nodes that are colluding so that they have more than 51% in determining that consensus. Now, this is not hypothetical. This has already happened with Ethereum. And this was actually the cause of the hard fork that Ethereum had. So again, the entire trust model that we are basing this stuff on is no longer even valid. Privacy issues, some of you might already know that, there's no anonymity, basically, in blockchain transactions, at least in public ones. And this has grand implications, like, for example, with things like GDPR. Can somebody tell me how you are going to make blockchain, you're going to make Bitcoin blockchain GDPR compliant? Yeah. Basically, you can't. And if you ask blockchain experts, sometimes they'll argue, yeah, but a wallet number is not personal details. Oh, really? I mean, pseudo-anonymous identifiers are personal details, and they fall under the GDPR as such. Another thing also is that OPSEC of devices is very difficult for most people. If you're coming up with these systems where you're planning on paying individual people, or again, coming back to these social enterprises using blockchain to pay these farmers in Africa, do you really think that this farmer in Africa knows how to manage the security of their endpoint devices? Of course they don't. So it's extremely dangerous to rely on people to maintain their own wallets on devices that they have no clue how to secure. But then what's the alternative? Cryptocurrency exchanges? The problem is you can't really trust those either. And there have been numerous cases of, cryptocurrency exchanges getting hacked. Yeah, oops, hacked. It could very well be that the people who started it, just took the money and ran. But how can you prove it, right? You can't necessarily trust these parties. But then at the end of the day, the question is, what exactly are we trusting here? So what is blockchain good for? I have to end on at least, a nice little positive note. Now, I think that there is a small, limited number of applications that blockchain is probably appropriate for, such as validating certificates in web browsers. But does that sound exciting enough to, deserve all the hype that this technology has been getting? Yeah, I don't think so either. Another thing also is that I think if you step away from the blockchain, cryptographic implementation for the moment, I think that the idea of decentralized contracts is also a potentially powerful one. But again, that's completely separate from the crypto implementation. Oftentimes, when folks say we need a blockchain because decentralization, think about it. You don't need a blockchain to build decentralized software. I believe in decentralization. I believe in open source, I believe also in making things scalable. But blockchain is not the way to do it. So we need to start putting our thinking hats on and asking really critical questions. We need to start with problems, and then from those problems, use the most appropriate technology to fix it. We need to stop saying, oh, I need to do something with blockchain. Yeah? Because the majority of this hype is being perpetuated by those with financial interest in this technology. So the next time you are thinking about doing something with blockchain, or you are wondering whether or not you should believe a particular presentation that is exclaiming that this particular blockchain application is the best thing ever, what I advise you to do, ask a security professional. We'll be able to tell you our real opinion. Thank you.
Thank you, Melanie, for a very brave and blunt talk. Do you see any possibility at all that in 5 years' time, when you're up here on the stage, that you might be saying that it's good for more than web certificates? Is there a chance that the overhyped meme, from your perspective, will actually become something a bit more robust and better? Or do you just think the odds of that are incredibly remote?
Look, as I said before, I believe that there's a small, limited number of applications that I believe blockchain will be useful for.
Okay.
But the problem is we're getting one side of the story almost always, and there's actually very few actual IT pioneers and security experts that are speaking publicly about this. I mean, look, I'm somewhat brave in being here because, what's likely to happen, it could be that a troll army of those who believe in the blockchain and cryptocurrency religion, very well can be critical, which is fine. Because again, I'm a security expert, but I think also that a lot of security experts have not been brave enough to get on a stage to say these kinds of things. I'm glad that a video is being made of this and is going to be put up on the web, because I think this is really an opposing voice that people need to hear.
And I have to say, as you know, I talk to an awful lot of major founders, and a huge percentage of them who have a deep engineering background have the same perspective. And there is fear out there because there's a lot of VC investment and stuff. So I think it's really important to voice the other side. And thank you for your bravery and for the excellence of your talk.
Thank you.
Really appreciate it. Dr. Melanie Rieback.
Okay, thank you.
Thanks a million.